So today we're going to be looking at transformations of graphs. Okay, we're going to be performing all these transformations using this power function of x to the third power. Okay, this is what x to the third power looks like. These 3 points are specifically for x to the third. All right, these are the most common 3 points you use for x to the third. So we're going to use those and see how each of our transformations moves this graph. Okay, and that's basically what we're doing. We're basically moving the graph around. Okay. So, here we go, the first one. Notice it is on the outside of the function. All right, outsides are going to be vertical shifts. Okay, and this particular vertical shift, because it's plus 4, is going to go up by 4. So the whole graph is going to be picked up and moved up by 4. Okay, so let's look at the graph first. So we pick up the whole graph, move it up by 4 spots. That point goes there. This point goes up here. The other point goes right there. The graph will look exactly the same. It's just been picked up and moved. Okay, if we look at the points, all right, since we're shifting up by 4, that's going to change the y values of your points. So each one of these points, the y value will increase by 4. So the first one we have -1. Negative 1 plus 4 is 3. If you add 0 and 4, you get 4. If you add 1 and 4, you get 5. You notice all these points correspond to the points we've already seen in the graph. So we're going to kind of go back and forth as to which one we do first. So 1, 5 is right here, 0, 4, and -1, 3. Okay, so those points correspond to the points we've already graphed because we shifted the graph up by 4. So this is a vertical shift up by 4. Let's look at the next one. So again, it is on the outside. So that means this is a vertical shift. But this time we're going down because it's negative. We're going down by 3. Okay, so let's do the points first this time. So we're going to take all the y values and for points and subtract 3 from them. So -1 minus 3 is -4. 0 minus 3 is -3. And 1 minus 3 is -2. So if we think about the graph, it's going to be picked up and moved down by 3 spots. And regraphed. Okay. And that's a vertical shift that's going down. All right, next, you'll notice that the next ones, they are not on the outside. They're on the inside of the function. Notice they're inside the parentheses. Okay, this is a horizontal shift. Okay. Now, with other things that we've seen in the past, when you take something out of the parentheses to solve for it, like we've done with our equations in the last test, it changes the sign. So although this says negative, you would expect it to go left. It's not. It's going to go the opposite. It's going to go right. So this is going to go right by 3. All right, this is going to change the x terms of your points, and it's going to change the graph to move left and right. In this case, particularly, it's right because it's a -3 inside the parentheses. So this is an inside function. Oops. So it's an inside change. Okay, so if we look at the x values, we're going to we're going to add 3 to each one of the x values. So -1 plus 3 is 2, -1, 3, 0, and 4, 0. Oh, sorry. That should be a 1. All right, so we're going to move all these places, or these points, over by 3 spots. So you're basically picking up the graph from where it was, moving it 3 spots to the right, and putting it back down. Okay. Again, notice this next one is an inside shift. It's inside the function, so it is going to be a horizontal shift. But this time, because it's +2, it's going to be going to the left by 2. Okay, so we're subtracting 2 from all the x values of our points. Let's do the graph first, though. So if I take these points and move them over by 2 to the left, 1, 2 is there, 2 is there, and 2 is there. I've picked up the graph, I've moved it 2 spots to the left, and I redrew it. Now we can do the points. I'm subtracting 2 from all the x values, so -1 minus 2 is -3, comma, -1, -2, comma, 0, and -1, comma, 0. And all these points correspond to the points that I've already put on the graph. Okay? All right, let's see the next thing. All right, so again, kind of in review, just because that's going to affect these two. Notice what happens on the outside versus the inside. So outside's vertical shifts, inside horizontal shifts when you're adding or subtracting. Now what we're doing is multiplying. We are multiplying the outside of the function, outside, by a negative number. Okay, this is going to reflect the graph over the x-axis. Oops. It's reflecting over the x-axis. So what that's going to change is all the y values are going to change. So I'm going to put that down. Change y values. All right. And it's going to change them by multiplying all of them by -1. So let's do the points first. So if I take all the y values and multiply them by -1, this is what happens. I get -1 for the x, but now a +1 for the y. -1 times 0 doesn't change anything because 0 times 0, anything is 0. And lastly, if I multiply the y value by -1 here, I'll get -1. How that will change our points is this point here will become down, this point here will go up, and the middle point will stay the same. So we reflected it over the x-axis. Okay. So you think about the x-axis as a mirror, you flip it over it, basically. All right. Now that's different when you change the inside and multiply the variable by a negative on the inside of the function. Okay, what this does, it's a reflection, but it's going to be over the y-axis. Okay. So what you're going to do in this case, you're going to change, you're going to change the x values. All right. So let's do the points first. So now this time, all of the x terms are going to be multiplied by -1. So you'll have -1 times -1 is +1 times, comma, -1. The 0, comma 0 does not change. Then you have -1, comma 1. All right. Now before you reflected it over the x-axis, this time we're reflecting over the y. So this point up here becomes this point here. This point over here becomes, the point on the bottom becomes this point over here. They look exactly the same as a reflection of the x-axis, but it's really technically not. Okay, it looks the same, but technically you did something different. Okay, and more complicated graphs that aren't necessarily pairing functions, it won't look exactly the same. Okay, so that's where we are with that. Next. Again, we're looking at something being done to the outside of the function. Okay, so this is a more complicated thing. If it is a number that's greater than 1, let's make it a little bit easier. If it's not a fraction, it is not a fraction, it is a vertical stretch. Now let's write that down here. All right, by a factor, let's just put by 5. Okay, so it's a vertical stretch. So what happens is this graph gets stretched out vertically. All right, again, because you're on the outside, it's going to affect the y values. Okay, so if you remember up to the first couple things we did, let's go back up to the top. When it's on the outside, like +4 and -3 were, it shifts it. It's a vertical shift. This is a vertical stretch. But all those things affected the y values. This is the same thing. Okay, rather than adding, though, we're going to be multiplying. So we're going to multiply the y values by 5. Okay, so we have -1, -5. The 0, 0 does not change, since 0 times 5 is 0. And then 1, 5 for the last point. So our points now are going to be up like this. So it's stretched the whole graph vertically. Okay. So now, if there is a fraction, this is what's going to be called a vertical compression. And we're going to say this is by a factor of 2. Okay, and the reason being is because it's just a technical thing for when you're speaking about vertical stretches and horizontal compressions later. We'll get to that in a second with dealing with fractions. Okay, so what you're going to be doing, again, this is on the outside, so it's going to affect the y value of your graph. But this time it's going to vertical compression versus vertical stretch. That means it's going to shrink the points closer versus spread them out. Okay, and it's, again, affecting the y values. So we're going to multiply the y values by 1/2. So you have -1, -1/2. The 0, 0 doesn't get affected. And then you have 1, 1/2. Okay, so I'm going to zoom in on the graph to give you a better idea. So now, rather than at 1, it's all at 1/2. This point doesn't change. Okay, so we've shrunk the space that it's going to take to get to those points by 1/2. Okay. All right, we got 2 more. Now you'll notice that this is an inside. So we're on the inside now. And inside functions or inside transformations affect the x-axis. This one is called a vertical... Sorry, my bad. A horizontal compression. Okay. That's going to be, so this is not a fraction. Okay, and it's a horizontal compression by 2. Okay, so this is going to happen when you change the x terms instead of the y terms, because horizontal stuff is changing the x terms. Okay, and what's that going to do is we're going to actually, it says multiply by 2, but it's a compression because you're actually taking the x value and you're dividing it. Okay, so we're going to divide all of our x terms by 2. So we get -1/2, -1. We have 0, 0. We have 1/2, 1. All right. So as a compression, it's going to shrink kind of like the other one did. Oh, sorry, wrong point. It puts the points here. All right, so we shrink along the x-axis. Okay, and the last one that we just did before this one, it shrank along the y-axis, so it made the points go down. This one's going to make the points go in towards the vertex, or the middle point of the graph. All right, last one, last change. This is a horizontal stretch. Okay, this is a fraction. All right, excuse me. And we're going to, this is by a factor of 2. Okay, so what we're going to do in this case is we're going to be multiplying the x terms by 2. Okay, so we have -2. Oh. We have 0, 0 still. We have +2. So now you're going to stretch it out along the x-axis. So we have -2 and -1, which is here. Here it's going to make it fatter. Okay. Now, important thing to recognize when you're doing these is how things are kind of like different. Okay, I want to kind of highlight that in these 4. So you notice if it's a whole number, not a fraction, it's a stretch for vertical, but a whole number is a compression for horizontal. Okay, a fraction for vertical is a compression, but a fraction for horizontal is a stretch. So they're reversed. Okay. So it's going to take some time to get used to these. It's really important that you practice. Okay, so let's look at some of these practices down here. Okay. So we're going to write the equation. How you're going to remember is going to actually have to be up to you. You're going to have to figure out some way to remember this. So I'm going to leave that one blank. But we're going to go through these notes here and show you what these look like if you just have the words and have to write the equation. So we're going up by 3. So g of x, I'm going to write down it in terms of f of x. You're going up by 3, so it's f of x plus 3. Okay. If you're going down by 7, it's f of x minus 7. Okay, notice these are both outside changes, so that means they are vertical. And they follow the sign that is on the number. So plus 3 goes up, minus 3 goes down. For the next one, left by 5, so we have f of x plus 5. You would think left would be minus, but that's going to be the opposite on the inside. This is the inside of the function. For the right, it's going to be f of x minus 9. So both those are inside functions and deal with the opposite of the sign of the number. Reflection over x-axis is negative f of x. Again, outside. Reflection over the y-axis is f of negative x. That's on the inside. Horizontal stretch is on the inside, f, and because it's a stretch, it's a fraction because it's opposite in horizontals. So we're going to put down, we'll do 1/2 again. Horizontal compression is going to be a whole number. I'll put 3 on the inside. Okay, vertical stretch is on the outside, and that's the opposite of what it would be for the other horizontals. So a vertical stretch is going to be a whole number. Let's put 5 times f of x. And a vertical compression is going to be a fraction. So we're going to put 1/5 times f of x. Okay. So you have to remember how to do these. My best suggestion is you have to practice these. They're not that difficult. It's just there's a lot of them, so it's going to be hard to remember. The actual doing of them is not that hard, but because there's so many of it, makes it the difficulty level go up a little bit. All right. Good luck with the practice. Ask questions if you need to.